Alrighty then. Let's pick up where we left off yesterday. So, yesterday we talked about x and y intercepts, which technically what we were doing is finding points of intersection. We are finding points of intersection between functions and one of those lines, either the x-axis or the y-axis. Today we're going to expand it a little bit and find point of intersections between two functions. So let's look at these two functions. Let's talk about the one on the left first. The x squared minus y equals 3. What can you tell me about that function? Go.
Quadratic.
It is a quadratic, which means what?
Which means it has 1, 2, or 0 intercepts on the x-axis.
Okay. What about this one in particular? Before we go there, let's be even simpler about it. What's it look like?
Parabola.
It's a parabola. Does it open up or down? Up?
Doesn't it?
I don't know. I'm asking you.
Up.
That was that. Up was a question.
No. No, 'cause
Anybody
it's
else?
like,
Up or down? Up?
Up.
Why?
Because it's positive.
What's positive?
The x.
The x. But the y is over with the x.
Because that's the interval that it's changing by.
Okay. Where's the vertex? Somebody else. 3. No, negative. Negative 3, correct. Okay. How about the second function? It's linear, okay, it's a line. So the question is, how many ways can a line and a parabola interact?
2 points.
2 points, that would be one way.
Or 1.
That would work if you had 2 lines, yeah. The line and a parabola doesn't work. Okay, so the first one you just described looks like this. That's 1. We'll use capital I because we're talking about cases here. How else? No, we heard enough. How do you put your hand down? Somebody else. John, right? Go ahead.
Just 1 point at the vertex.
What's that called? You're right. You're talking about, you want to put it at the vertex?
Yeah.
Down here?
Yeah.
Does it have to be at the vertex? You're driving the bus. We can put it at the that's fine. But could I put it over here?
Yeah.
Yeah. Do you know what that's called? Good. It's tangent. Look, that dot's back.
Over it, okay.
Wait, it's still there. No.
That's 2. Any more? Can you get 3 points? No, you can't.
Okay.
But there is another case. What's case 3? Good. No points of intersection, 1 point of intersection, 2 points of intersection. Okay, and this is with a line and a parabola. We should have started with something simpler, and that is, what about 2 lines? Intersect in a point, never intersect, or the same line. This can get uglier if we look at something like, oh, I don't know. Let's take a cubic looking thing, and I'm feeling kind of saucy here. Let's use this. Wow. That was supposed to be a circle. Let me try that again. A circle. How many different ways can those puppies intersect? I gave you 1, that's 0 intersections. Can you get 1 intersection? Yeah, move the circle over till it's just touching or tangent to the graph. Can you get 2? Yeah, move the circle over a little bit further so that line-looking thing goes through it. Can you get 3? And you see it can get uglier and uglier. We could probably get 4 here. We could maybe get 5. Could we get 5? 1, 2, 3. I don't know if I'd get 5. Maybe 4. regardless, you can see how ugly it gets. So we're going to start with something fairly similar, or fairly simple, which is this parabola and the line. Which means it's going to be one of these three cases that I just, in my infinite wisdom, erased. Which one do you guess? 2 intersections, 1 intersection, no intersections. It doesn't matter, we're going to solve it anyways. 2? All right, probably. It is 2. I cheated and showed you the graph first, then we're going to do the math to figure out where those 2 points of intersection. But you already know the answers. We should get 2, 1 and negative 1, 2. So let's do the math now. First thing I'm going to do, set the equations equal to y. This is a little bit easier. That's not always going to work. You might get functions where you're incapable of solving for y. Or if you solve for y, it gets way too nasty. This one works out nice. What's next? Is it just because you guys are bashful or that you don't know? Why do I ask questions? You're not going to answer them. I'll start picking on people to help me learn names. Cindy, put your hand up. You lose all the blood flow in your arm. Tell me your name. When you're done drinking. Victor, what are you going to do next? Beautiful. Okay, do that. What happens? Victor? Set them equal?
Yeah.
Then what? Okay, so I set them equal. What do I do next?
Solve.
Good. How? I don't think you got the joke. Anybody else? Please tell me somebody got. Okay, thank you. It wasn't great, but it's the best I could do in short notice. Notice? Notice. Move what to where? Shut up, Rachel. Yeah. Still picking on you. Good, now be specific. You want to move the x over there, you want to bring the x squared over here. The great thing is there's no wrong answer. It's just what you want to do. It's all about you, Victor. What do you like it? It's a good call. What are you going to do with the negative 1? That the x is going to leave behind when it goes to the other side. You want to leave it there, or you want to bring that over with it too? Keep them together like friends. Move it too? Okay, so if I'm doing my math correctly, then the left side will become x squared minus x minus 2. Right, Victor?
Yes.
Good. What's the right side become?
0.
At a point. Now what, Victor? Last question, then I'll leave you alone. Good. Ends up with a nice, pretty quadratic, which factors. And just like in a lot of math, we get nice, pretty answers, and everybody's happy. But we knew that already because we saw the picture. You won't always get nice, pretty answers. And this is why you might need your quadratic formula, because if it turns into a quadratic that is horrendous, you need to be able to solve that either factoring quadratic formula using your calculator. But this one works out real nice. X is 2 and negative 1. That doesn't answer the question, because the question says, where are the points of intersection? And points of intersection are points. So I'm missing the y coordinates. How do I find the y coordinates, Max? Which one would you prefer, sir?
X minus y is
Yeah, I'd probably put it in there too. Nice, easy linear equation.
the y is equal to x minus y.
Yeah. Whatever you want. It's one of the great things about this country. Okay, so there we go. Depending on the functions that you're given, that can become more difficult. Finding the intersection of two lines for you should be pretty easy. You see it gets a little bit more difficult when you intersect a line with a quadratic. You can pretty much intersect any functions with any other function. It just depends on how ugly the math is and how well you can deal with that math. Are we good with that? Okay. What are the mother functions? Izzy, what are the mother functions? Or, bonus question, can you give me an example of a mother function? Dude, rocking the Crocs. Nice. Are you Walt Disney?
Yeah, I got a bunch. Well, there's a football.
I don't know why
Are you gonna get new ones?
Yeah, I'm getting the yellow ones, and then they came out with these new maroon ones that I really like. And my friend works there, so I get 50% off everything. And normally it's like $40.
So my daughter, who's a sophomore at IU, thought she was gonna bring Crocs to IU. You know, like she was gonna be the trendsetter.
Yeah.
So she got a pair of red Crocs, packed in freshman year, and people were like, the hell are you doing?
Oh, no. Like, I already get that response, but like, who cares? They're Crocs.
The Crocs are so expensive.
But those,
Gibbets.
Gibbets, I couldn't remember what they're called. Yeah. It might come as a
You
shock,
fuzzy
but I have a
Crocs?
couple of
I
Batman
don't have
Gibbets.
fuzzy Crocs.
Do you want fuzzy Crocs?
No.
I
Fuzzy
said-
Crocs?
I said pink ones with white fuzzy.
I feel like they get really
Wait, I had those.
Wait, hold on, back up. What's a fuzzy Croc?
They have like
It's
fur on
like
the
fur.
inside.
It's like
It's like us, except like Crocs.
What?
So it's Croc and then inside is like fur.
And because your feet already get sweaty in the plastic, and then
Two
already with the fur.
No.
Yeah, but in the
way.
fur you wouldn't have the holes, so they wouldn't breathe, right? At least with
No,
those.
there are holes
Those
still.
are there.
But like,
It's really
it's
cool.
just
It's just like socks. And you take the socks off, you don't want the
I
socks.
almost it's like black.
Who wears
So-
socks?
Why would you get why would you get the fuzzy ones?
What do you wear, socks and Crocs for? Doesn't
Because
it-
then
The
my
winter
feet don't get like
times,
nasty.
like slippers.
But you're
Wearing Crocs.
I don't wear it. I wear the straps on.
Learn them around
Oh.
the house.
I don't have straps,
Because
but
then
like
they come
when
off,
I was
'cause people
little,
step on
I
them.
did.
I had Crocs.
Sorry for that,
They're too small, I
I've
started.
never
sorry for
owned a
that,
pair of Crocs.
sidebar there, but we had to get this out.
My
They're-
father
they're
would let
pink
me
and white.
Crocs because there was a story
Yeah.
when the children get
They were
stuck in
eyeballs.
splitters.
Okay, Izzy, we're back to you. I don't know if you ever answered, I got sidetracked by the bright colors over
I
there.
feel
I like
that.
the Dust Bowl picture.
Beautiful, quadratic. I'm not gonna click because there's one that's before quadratic and I don't wanna give it away. What's simpler than a quadratic? Beautiful. Okay, so we got a linear. The most basic type of function we're gonna deal with. Why are you writing that down?
Yeah, so same, I was thinking the same thing.
Quadratic. Don't write that down. What's next? Cubic. Good. What's next?
Quartic?
Yeah, we're not gonna deal with quartic. I didn't list it. But we could go quartic, quintic, hextic, septic, octic, all those. We're not gonna do much past a cubic. Some other ones. Go. Wait, tell me your name first. Anthony.
Square root.
Beautiful. I hope I listed that, but I'm not gonna click because I don't remember what the next one is. Let's just get a whole bunch. Tell me your name.
Michael.
Michael.
Reciprocal.
Reciprocal function. I don't think I listed that one. What's a reciprocal function look like?
Isn't it? I don't know. It's like-
Okay, I don't want to lead you into an answer. What's the reciprocal function? Give me an example of a reciprocal function.
1/n.
Beautiful. Anybody know what that puppy looks like?
That's asymptotes.
Yeah, this is it's that thing. This guy. And that's.
Those are for the graph. I actually learned to love
That was like the best part about you. I loved those.
Easy point.
Just have a thing for reciprocal function.
They look kind
Wait, I think I forgot that one.
I kind of like imagine like a person like, yeah. No, I
Once you got it
Who's
down,
like,
6
it's like, like here and like here.
Let's see. Absolute value. Of course, I forgot that one. What's absolute value look like? It's the V, right? Yeah. We'll do a lot with that. Oh, semicircles. I think we may need to talk about these, right?
Yeah, that's.
Why aren't we doing circles?
Not the value.
Aren't functions.
Not functions. Good. Okay, so semicircles. Let's start with a basic circle equation. So we'll deal with a circle at the origin with the radius of r. General formula, right? We'll go simple here. And I'm sure you all remember that if you move it left or right, it changes and you get an x minus h quantity squared, but we don't care about that. This is the entire circle, not a function. Why isn't it a function? Because it doesn't pass the vertical line. That's great. If we solve this for y squared equals r squared minus... What mistake did I just make?
You can't. The square root of like a. I don't know.
Yeah, you can.
No?
Plus or minus.
Plus or minus. Yeah. Now, that plus or minus is very important here because we're taking a square root, you gotta have a plus or minus, and each one of those represents something different. The plus, this guy, represents the top half of the circle, the top semicircle. The minus represents the bottom half. Smiley face, frowny face. Bonus question. What's the equation of that thing?
X.
Hmm?
Switch to X and Y.
Yeah. Solve for x. X is equal to plus or minus square root of r squared minus y squared. Positive is the right side. Negative is the left side. We don't deal with these a lot because, again, they're not functions. Top and bottom, you should know these. We good?
Yes.
Exponentials. Those are fun. What does an exponential look like? Anybody know? Good. Grows very fast. Square roots. What's on there? I wasn't sure. I don't know if I have one more on there.
Running out of space.
What's that?
We were running out of space.
Yeah. I didn't have another. I should have had reciprocal functions on there. So we're done. Like I said, it's a quick lesson for today. This will wrap up the first section of that, and we're good to go. So in the time that we have left, hold on one second, kids.